So when we're going to be referring to the relationship between two angles created when lines are cut by a transversal, we might use more than one name to talk about the relationship between the angles. Okay, so we have, here are my two lines, line T and line S. They're going to, I'm sorry, line R and line S, they're going to be cut by transversal T. Angles 1 and 5 are corresponding. Angles 3 and 7 are corresponding because they are in the same position, either upper left or lower right. Now, the two interior angles that have different vertices would be called alternate interior angles. So, angle 4 and angle 7 are alternate because they're not on the same side, they're on alternating sides of the transversal, interior. These angles are alternate interior angles. Angle 3 and angle 6 are also alternate interior angles. Let's look at angle 2 and angle 7. They would be alternate because they're on opposite sides of the transversal, exterior angles because they're both on the outside. They're both on the outside of the two lines that are cut by the transversal. So alternate interior and alternate exterior, those are angles that are taken together as pairs. That would be angle 2 and angle 7. Oh, this should be angle 2 and angle 5. So we've talked about alternate exterior angles and alternate interior angles, and those descriptions are always taken in pairs. Now what about if parallel lines are cut by a transversal? Up until now we've talked about any two lines cut by a transversal. What if the parallel lines are cut by a transversal? We still have these 8 angles that get created, and we can either call them corresponding or we can call them alternate interior or alternate exterior. We could call them same side interior. But certain relationships will hold when the lines that are cut are parallel. The first postulate is that if two parallel lines are cut by a transversal, corresponding angles are congruent. Same shape and same size. That's what congruent means. So, if I have line P and line Q cut by transversal T, angle 1 and angle 2, since they are corresponding, since they're both in the lower left, we would say that angle 1 is congruent with angle 2 because parallel lines cut by a transversal, corresponding angles are congruent. If this is angle 4 and this is angle 8, we would say that angle 4 is congruent with angle 8 because corresponding angles are congruent when parallel lines are cut by a transversal. Notice here we have the angles are congruent. The angles are congruent. The measure of angle 1 would equal the measure of angle 2. Angle measures are equal, angles are congruent. Measure of angle 4 would equal the measure of angle 8. Angle measures are equal, angles are congruent. Okay, so let's go through an example here. Now, you can think of it this way. Parallel lines cut by a transversal, unless they're perpendicular, there's always going to be a big angle measure and there's going to be a smaller angle measure. So 1 and 5 are corresponding angles. They're going to have the same measure. 5 and 8 are vertical angles. They're going to have the same measure because vertical angles are congruent. So in our problem, L is parallel with M, and the measure of angle 1 is 117. And it looks like a 117 degree angle, right? It's larger than 90 degrees. So they want us to find the measure of angle 2. So let's use good geometry here. The measure of angle 1 plus the measure of angle 2 is going to be a straight line. Measure of angle 1 plus measure of angle 2 is going to equal line L. And we're told the measure of angle 1 is 117, so I'm going to replace the measure of angle 1 with 117. Bring down the plus, bring the measure of angle 2, bring down the equals, bring down the 180. And we want to get the measure of angle 2 by itself. So we're going to subtract 117 degrees from both sides. And we're going to get the measure of angle 2 is going to equal 180 minus 117 is 63 degrees. So the measure of angle 2 is going to be 63 degrees. All right, so if the measure of angle 1 is 117, the measure of angle 5 is going to be 117 because they are corresponding. If the measure of angle 2 is 63 degrees, the measure of angle 6 is also going to be 63 degrees. But they didn't ask us for angle 6. What did they ask us for? They asked us for angle 4. Angle 1 and angle 4 are vertical angles. Intersecting lines create pairs of vertical angles, so the measure of angle 4 is 117. And if the measure of angle 4 is 117, that would mean the measure of angle 8 is also 117 because they're corresponding. So what you're going to notice is parallel lines cut by a transversal. There's going to be a large angle measurement, something greater than 90, and all the big angles will have that measurement. Like all the big angles here, all the obtuse angles will all be 117. All the acute angles here will have a measure of 63. Here's another theorem. If two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. So parallel lines cut by a transversal. If this is angle 1, and this is the pairs of alternate exterior angles are congruent. That's angle 1 and that's angle 8. They are both the bigger angle. They're alternate because they're on opposite sides of the transversal. Exterior because they're outside the parallel lines. They are also congruent. So angle 1 would be congruent with angle 8. Corresponding angles are congruent. Alternate exterior angles are congruent. And there are many other relationships that get created when you have parallel lines cut by a transversal. The two same side interior are going to be supplementary. They'll add up to a straight line. Same side exterior will also be supplementary. So here are parallel lines cut by a transversal. Angle 1 and angle 2 are same side interior. The measure of angle 1 plus the measure of angle 2 will equal 180. We've got a big angle and a small angle. And same side exterior, so let's call this 3 and let's call this 5. Same side exterior will also, measure of angle 3 plus the measure of angle 5 will also be supplementary. Add up to 180. So parallel lines cut by a transversal, you have a big angle and a small angle. The big angles are all congruent with each other. The small angles are all congruent with each other. And the larger angle and the smaller angle together will be supplementary. If two parallel lines are cut by a transversal, then the pair of interior angles on the same side are supplementary. We just had angle 1 and angle 3. That's a diagram I just basically drew. And we've also drawn that if two parallel lines are cut by a transversal, the exterior, same side exterior angles are supplementary. So let's end with an example here. Here we're told that the line TV is parallel to the line WY. And obviously there's a line RS, which is a transversal cutting it. So if the measure of angle RUV is x plus 4 times x minus 3, and the measure of angle WXS is x squared minus 3, what's the relationship between those two angles? They are alternate exterior angles, which means they're congruent, which means their measures are equal. So that means x plus 4 times x minus 3 is going to equal x squared minus 3. And now we've got our algebra. We're going to FOIL this first, outside, inside, last. X squared minus 3x plus 4x minus 12 is going to equal x squared minus 3. And the way we solve these is we set these equal to 0. So let's subtract x squared from both sides. All right, well, that's going to eliminate x squared from both sides, and we're left with negative 3x plus 4x minus 12 is going to equal negative 3. Let's combine these terms. Negative 3x and positive 4 is a x. X minus 12 equals negative 3, and we want to get x by itself, so we're going to add 12 to both sides. And we get x equals 9. And let's check our answer. 9 plus 4 times 9 minus 3. What does that equal? 9 squared minus 3. What does that equal? So this is going to be 13 times 6. What does that equal? And what is 81 minus 3? And 13 minus 6 is 78. So this is a 78-degree angle. And 81 minus 3 is also 78. So they are congruent angles.